Hello everyone and welcome to the lecture on Amazon SageMaker. So this lecture will contain all these topics. What is Amazon SageMaker? Overview of machine learning with Amazon SageMaker. Major features. Machine learning environments. Amazon SageMaker domain overview. Automated ML no code or low code solution. SageMaker autopilot. Train, deploy and evaluate pre-trained models with SageMaker Jumpstart. Amazon SageMaker ground truth. So what is Amazon SageMaker? Amazon SageMaker is a comprehensive, fully managed machine learning service provided by AWS. It handles the entire machine learning workflow, allowing data scientists and developers to focus on their core tasks. SageMaker enables users to quickly and confidently build, train and deploy machine learning models. This streamlined process significantly reduces the time from concept to production-ready models. SageMaker provides a user-friendly interface for running machine learning workflows. This user interface makes SageMaker's ML tools accessible across multiple integrated development environments (IDEs), enhancing flexibility and ease of use. With SageMaker, users can store and share their data without the need to build and manage their own servers. This feature simplifies data management and reduces infrastructure overhead. By eliminating the need for server management, SageMaker gives organizations more time to collaboratively build and deploy ML workflows. This promotes teamwork and accelerates the development process. SageMaker offers managed ML algorithms that can efficiently process extremely large datasets in a distributed environment. This capability allows for handling big data ML tasks without worrying about the underlying infrastructure. SageMaker provides built-in support for custom algorithms and frameworks. This flexibility allows data scientists to use their preferred tools and methodologies within the SageMaker environment. The platform offers flexible distributed training options that can be adjusted to specific workflows. This adaptability ensures that SageMaker can accommodate a wide range of ML training requirements. Within just a few steps, users can deploy their models into a secure and scalable environment directly from SageMaker console. This feature ensures that ML models can be quickly put into production with robust security and scalability. Overview of machine learning process with Amazon SageMaker. So machine learning workflow with Amazon SageMaker. So first you generate example data. So there will be a couple of steps. You will fetch from repositories, which is basically you gather data from in-house or public sources. Then step B would be clean and standardized. So you ensure consistency and correct formatting of data which is required. Then within that you will have prepare and transform stage, wherein you combine or modify attributes to enhance model performance. So this will be in a circular loop. So it will start from this stage which I just talked about, then it will go to second, and then I will be covering third and fourth. And after that you have train model stage or a phase wherein you choose algorithm. So you can select from SageMaker's built-in options or use custom algorithms. Then you train with data. You can use the prepared data to teach the model patterns and relationships within the data. And finally, you will evaluate the accuracy. You will test the model's performance and assess its inference accuracy. Inference is a term which we say like how it predicted, like what is the inference and how accurate that is. Like is it 90%, 80%, 85, 95%. Then after that you have these two stages, deploy and monitor. So deploy and improve. So you have step inside that deploy independently. You can use SageMaker to deploy the model separately from application code. So basically the prepared model which you have to deploy separately. So that does not have the code. It's a final whatever we call executable, and that's get deployed. Then you have monitor and collect new data. And after that you observe real world performance and gather fresh high quality data. So you have the training data and you have trained the model, but now it has gone into production and it will be encountering new real world performance and fresh data. Then you can retrain for accuracy. So once you have the new real world data, you can retrain again for higher accuracy. So you continuously update the model with new data to improve accuracy and combat drift. So you start with training data, which is a baseline. Then you get real world data. So after every few months or few weeks, You can gather all the real world data and again retrain the model and redeploy back. So that is why this goes into a circular loop. So you start like day one, you have data, you prepare a model, you train, evaluate, you put to production, you get new data, it's get bombarded with new data, then you take all that new data and you have some accuracy, you again make the new data as part of again model retraining, then evaluate model, because you have let's say version 1 and here you have version 2. So version 2 should hopefully do better than version 1, and if it's good enough, then you again put it back into production, and this can go on forever. Now I'll be talking the major features of SageMaker. So first is Amazon Augmented AI. So build the workflows required for human review of ML predictions. Amazon Augmented AI A2I brings human review to all developers, removing the undifferentiated heavy lifting associated with building human review systems or managing large numbers of human reviewers. Next feature is AutoML step. You can create an AutoML job to automatically train a model in SageMaker pipelines. Third one, SageMaker Autopilot. Users without machine learning knowledge can quickly build classification and regression models. Batch transform. Pre-process datasets, run inference when you don't need a persistent endpoint, and associate input records with inferences to assist the interpretation of results. SageMaker Clarify. Improve your machine learning models by detecting potential bias and help explain the predictions that models make. Next one, collaboration with shared spaces. A shared space consists of shared Jupyter server application and a shared directory. All user profiles in Amazon SageMaker domain have access to all shared spaces in the domain. SageMaker Data Wrangler. You can import, analyze, prepare and featurize data in SageMaker Studio. You can integrate Data Wrangler into your machine learning workflows to simplify and streamline data pre-processing and feature engineering using little to no coding. You can also add your own Python scripts and transformations to customize your data prep workflow. Next feature is Data Wrangler data preparation widget, and you can interact with your data, get visualizations, explore actionable insights and fix data quality issues. SageMaker Debugger. Inspect training parameters and data throughout the training process. Automatically detect and alert users to commonly occurring errors such as parameter values getting too large or too small. SageMaker Edge Manager. Optimize custom models for edge devices. Create and manage fleets and run models with an efficient runtime. Next feature, SageMaker Elastic Inference. Speed up the throughput and decrease the latency of getting real-time inferences. Next feature is SageMaker Experiments. Experiment management and tracking. You can use the tracked data to reconstruct an experiment, incrementally build on experiments conducted by peers, and trace model lineage for compliance and audit verifications. Okay, next feature, feature number 13. So this is actually a very long list, so I'll just quickly run through it. SageMaker Feature Store. A centralized store for features and associated metadata, so features can be easily discovered and reused. You can create two types of stores, an offline and online store. The online store can be used for low latency, real-time inference use cases, and offline store can be used for training and batch inference. SageMaker Ground Truth. High quality training datasets by using workers along with machine learning to create labeled datasets. SageMaker Ground Truth Plus. A turnkey data labeling feature to create high quality training datasets without having to build labeling applications and manage the labeling workforce on your own. SageMaker Inference Recommender. Get recommendations on inference instance types and configurations, for example, instance count, container parameters and model optimizations to use your ML models and workloads. Inference Shadow Test. Evaluate any changes to your model serving infrastructure by comparing its performance against the currently deployed infrastructure. SageMaker Jumpstart. You can learn about SageMaker features and capabilities through curated one-click solutions, example notebooks and pre-trained models that you can deploy. You can also fine-tune the models and deploy them. So this is the Jumpstart, which will help you learn all the features and capabilities through curated one-click solutions. SageMaker ML Lineage Tracking. Track the lineage of machine learning workflows. SageMaker model building pipelines. Create and manage machine learning pipelines integrated directly with SageMaker jobs. SageMaker model cards. Document information about your ML models in a single place for streamlined governance and reporting throughout the ML lifecycle. SageMaker model dashboard. A pre-built visual overview of all the models in your account. Model dashboard integrates information from SageMaker Model Monitor, Transform Jobs, Endpoints, Lineage Tracking, and CloudWatch, so you can access high-level model information and track model performance in one unified view. SageMaker Model Monitor. You can monitor and analyze models in production endpoints to detect data drift and deviations in model quality. SageMaker Model Registry. So this helps in versioning, artifact, and lineage tracking, approval workflow, and cross-account support for deployment of your machine learning models. Feature number 25, SageMaker Neo. Train machine learning models once and then run anywhere in the cloud and at the edge devices. Notebook-based workflows. Run your SageMaker Studio Notebook as a non-interactive scheduled job. Pre-processing. You can analyze and pre-process data, tackle feature engineering, and evaluate models. SageMaker projects. Create end-to-end ML solutions with CI/CD by using SageMaker projects. Reinforcement learning. Maximize the long-term reward that an agent receives as a result of its actions. SageMaker Role Manager. Administrators can define least privilege permissions for common ML activities using custom and pre-configured persona-based IAM roles. SageMaker Serverless Endpoints. A serverless endpoint option for hosting your ML model automatically scales in capacity to serve your endpoint traffic, removes the need to select instance types or manage scaling policies on an endpoint. Studio Classic Git extension. A Git extension to enter the URL of a Git repository, clone it into your environment, push changes, and view commit history. SageMaker Studio Notebooks. The next generation of SageMaker notebooks that include AWS IAM Identity Center integration, which is AWS single sign-on, and fast startup times and single-click sharing. SageMaker Studio Notebooks and Amazon EMR. You can easily discover, connect to, create, terminate, and manage Amazon EMR clusters in single account and cross-account configurations directly from SageMaker Studio. SageMaker Training Compiler. You can train deep learning models faster on scalable GPU instances managed by SageMaker. Okay, so next is machine learning environments. So first one, SageMaker Geospatial capabilities. So you can build, train, and deploy machine learning models using geospatial data. So geospatial is geographical. So basically like based on the geography of locations, latitude and longitude based data. So you can train your ML models using that kind of data. SageMaker Canvas, an auto ML service that gives people with no coding experience the ability to build models and make predictions with them. SageMaker Studio, an integrated machine learning environment where you can build, train, deploy, and analyze your models all in the same place. SageMaker Studio Lab, a free service that gives customer access to AWS compute resources in an environment based on open source Jupyter Lab. Then RStudio on Amazon SageMaker, an integrated development environment for R language with a console, syntax highlighting editor that supports direct code execution, and tools for plotting, history, debugging, and workspace management. So SageMaker Studio is the most preferred and common, but in case you have some other like Geospatial or RStudio or something, you can use other one, but most of the time you will end up using SageMaker Studio. Okay, next Amazon SageMaker Domain. So domain is how you actually, it's one of the building blocks of working with SageMaker. So SageMaker Domain is a crucial component for accessing SageMaker environments and resources. And to gain access, users must complete a domain onboarding process through SageMaker console. Basically, you go to SageMaker service and you do a onboarding and you create a domain. So SageMaker domain components. Domain comprises of first an Amazon Elastic File System EFS volume. Then you have authorized users and other various configurations like security, applications, policies, and you will have Amazon Virtual Private Cloud VPC. Then the domain structure consists of 4 main entities. So a domain includes an EFS volume, the authorized users, and configuration settings. Note: users can share notebook files and artifacts within a domain. Multiple domains per account are possible. So per account is per AWS account. So you can have multiple domains for every AWS account, and within that domain you can share notebook files and artifacts within a single domain. Then user profile. User profiles represent individual users within a domain, and this facilitate sharing, reporting, and other user-oriented features. Basically, user management is done through user profiles. Shared space. A shared space provides 1. A common Jupyter server application. 2. A shared directory accessible to all users within the domain. Next is app. An app supports the execution of notebooks, terminals, and consoles. So there are few available app types. One is Jupyter server. Next one is kernel gateway, which is an execution environment for kernels. RStudio Server Pro, which is an RStudio IDE for R development, and R Session for interactive R programming. Tip: users can have multiple apps active simultaneously. So benefits of SageMaker domain architecture: 1. Efficient collaboration. 2. Effective resource management. Amazon SageMaker machine learning environments provide a flexible and secure platform for data scientists and developers to work on their projects. Okay, next is automated machine learning using either no code or low code. So there are two solutions. One is autopilot, and next one is jumpstart. So both of them are basically no code or low code. So no code is, there is no code involved. Basically you have point and click, and low code probably is jumpstart, where you have to write very less code. Like you just have to give some configuration or maybe write very less scripts or code. So these two, there are two solutions under that. So first one, Amazon SageMaker Autopilot is an automated machine learning AutoML feature set that automates the end-to-end process of building, training, tuning, and deploying machine learning models. Amazon SageMaker Autopilot analyzes your data, selects algorithms suitable for your problem type, pre-processes the data to prepare it for training, handles automatic model training, and performs hyperparameter optimization to find the best performing model for your data set. Next is Jumpstart. So SageMaker Jumpstart provides pre-trained open source models for a wide range of problem types to help you get started with machine learning. You can incrementally train and tune these models before deployment. Jumpstart also provides solution templates that set up infrastructure for common use cases and executable example notebooks for machine learning with SageMaker. So Autopilot will not only identify the problem type, it will even evaluate all the different models. It will choose the best model. It will evaluate, and it will tell you which model should go for production, like which model. It will give a final candidate after testing multiple models. So this may be time consuming and will also cost you more. But Jumpstart is something you have some idea, like you can use this model or that model because they are pre-trained models. So you have some idea, so you can choose one of them, and you have some templates and example notebooks. So that will just speed up the ML development process. So this one is like no code, and this one is low code. So because this one you have no idea, so you have a problem, you have data, but you don't know what type of problem you are trying to solve, which algorithm should it choose. So you just feed in the data. It will figure out everything on its own. It will evaluate multiple models. It will run parallelly, and it will give you one final model that will solve your problem. Okay, SageMaker Autopilot. So I'll be covering both one by one. So first one is Autopilot. So Autopilot is a feature that simplifies and accelerates various stages of machine learning workflow by automating the process of building and deploying machine learning models, AutoML. So some key features are, it will identify a specific problem type. It can handle missing values. It can normalize data by itself. It can select features by itself. It can prepare data for model training. Then comes under model selection, it will explore various algorithms. It can use cross-validation resampling technique. It can generate metrics to evaluate predictive quality, and it can and based on those, it can based on predefined objective metrics, like what is the objective that like what metric you want to evaluate. Then it can do hyperparameter optimization. It automates search for optimal hyperparameter configurations. And finally, model training and evaluation. So it can automate training and evaluation of model candidates. It can split data into training and validation sets. It trains selected model candidates using the training data. It evaluates performance on unseen validation data. It ranks optimized model candidates based on performance. And finally, it identifies the best performing model. Then finally, and last step will be the model deployment. So it provides option for automatic deployment. It generates model artifacts. It creates endpoint exposing an API, and it allows external applications to send data to the endpoint, and it can receive corresponding predictions or inferences. Note: Autopilot supports building machine learning models on large datasets up to hundreds of GBs. And some supported problem types are tabular data. You have CSV or Parquet files, and the problem types can be regression, binary classification, multi-class classification. Each column contains a feature with a specific data type, and each row contains an observation. Accepted column data types include numerical, like numbers; categorical, like it belongs to a certain category, like group A, group B, group C. Then text, like a free flow text, and time series, which is basically strings of comma separated numbers. And next, text classification. Again, if you have CSV or Parquet files, one column provides sentences to be classified, and another column provides corresponding class label. So you have text, and what is the category? So label is something like what you want to categorize the data, the text to be. So it will have, let's say, dog and cat problem, which we have seen. So it will have photos of. So this is not okay. Let's say some sentiment, right? Positive or negative, and you have text like reviews, and you have given it 100 example, like positive or negative. So it will figure out. So AutoML will figure out, okay, this is the label is either positive or negative. It will categorize by itself. Okay, what are different categories based on the text that it has encountered. Then third one is image classification. So it supports PNG, JPEG, or combination of both. Then time series forecasting. So under image classification, the previous example which I was giving. So if you have many images, for example, some product, either it's defective or not, you can just feed in many images, and you will label them or may not label them, but AutoML will figure out, okay, you are some are defective and non-defective, and it will figure out the problem type, and it will give you the model options. Then you have time series forecasting for both CSV or Parquet files, and then fine tuning of large language models, LLMs, something like ChatGPT, Claude, for text generation, CSV or Parquet files. And important, the specific file format, CSV or Parquet, and data structure requirements may vary depending on the problem type. Okay, next is Jumpstart, the other part. We have seen the no code, now we'll see the low code. So train, deploy, and evaluate pre-trained models with SageMaker Jumpstart. So Jumpstart is a comprehensive toolset within SageMaker that facilitates training, deployment, and evaluation of pre-trained models. It offers a wide array of open source pre-trained models for various problem types. It has the capability for incremental training and fine-tuning of models before deployment. There are solution templates for common use cases, and you have the executable example notebooks also. So access interface, Jumpstart is accessible through two main interfaces. One is Studio, I talked about, SageMaker Studio, which has you can deploy pre-trained models, you can fine-tune models, and you can evaluate models from popular model hubs. Then Amazon SageMaker Studio Classic, wherein you can also access pre-trained models, use solution templates, and explore examples. So some foundation models. A key feature of Jumpstart is its provision of the state-of-the-art foundation models. And some characteristics are, they are large pre-trained models already available, and they are versatile and adaptable to numerous downstream tasks. They serve as a starting point for more specialized models. Use cases. So Jumpstart foundation models cater to various applications, including content writing, code generation, question answering, copywriting, summarization, classification, and information retrieval. So some examples are, actually the list is very long, I put the very popular ones which are available right now. So one is Llama 370B, which is a very popular model. It's a large language model. Then you have Bloom 176B, which is a multilingual language model. Flan T5XL, which is an instruction tuned text-to-text model. And GPT-J6B, which is a GPT-like model, but not ChatGPT, but GPT-like model. And all these models are pre-trained on extensive text data and can be fine-tuned for specific language tasks. And integration and customization. Jumpstart streamlines the integration of foundation models into machine learning life cycles by onboarding publicly available models. You can maintain these models for easy access. You can enabling users to customize and incorporate models into their own generative AI solutions, and allowing integration with additional SageMaker features. Important, this feature set allows users to leverage pre-trained and foundation models effectively in their machine learning projects. So let's say you work for a client and they want to use some, let's say open source model like Llama 370B, right? So you can train it on, for example, with the client data on SageMaker, and you can deploy it there. So basically in Jumpstart you will see all this. You don't have to upload anything. It's all will be available for you. All you have to do is train, test, and finally use the model. So benefits are tools and resources to expedite development, methods to enhance model performance and streamline access to the state-of-the-art models, flexibility in model customization and deployment. One tip, you can leverage Jumpstart to accelerate your machine learning projects and explore cutting-edge AI technologies. Okay, next last feature is Amazon SageMaker Ground Truth. So Amazon SageMaker Ground Truth is a service designed to facilitate the creation of high quality labeled datasets for machine learning models. These datasets are crucial for training accurate and effective ML models. Ground Truth offers a flexible approach to data labeling by allowing users to leverage various workforce options. These include Amazon Mechanical Turk, with over 500,000 independent contractors worldwide. Then private workforces. This is created from your employees or contractors, like you own. So you will outsource it, like you will not ask Amazon. So first one is you ask Amazon to use their contractors, or you can provide your own private workforces. And finally, all specialized vendor companies from AWS Marketplace. So you can choose one of them from these three. And this diversity enables organizations to choose the most appropriate labeling team based on their specific data handling requirements and sensitivity. So basically, if you have a data, for example, images, it's not like it will be hundred or thousands. It can be in millions, and it can take a long time to label. Like it can be have one or two label, or it can have multiple labels, right? So if you want to label, it can take a long time, and it will be very time consuming. So you can take the service of any one of them, like 3 out of 3, you can take one of their service. So Ground Truth provides both built-in and custom labeling workflows to suit different ML applications. Users can select from predefined task types for common labeling needs, or create custom labeling processes with their own interface and tools. This flexibility allows for optimized labeling process tailored to specific data types or requirements. Basically, this task will tell through Amazon SageMaker console, like what you want what you want to look for. Basically, you have to give some example or put some text description and all, and then whoever you hire to do the labeling task, they will have more idea like how to go about labeling your data set. And to streamline the labeling process, Ground Truth offers automated data labeling. This feature employs machine learning to determine which data requires human labeling, potentially reducing time and effort in the labeling process. It's an optional feature that can significantly improve efficiency in large-scale labeling projects. So if you have millions and millions of data sets, and you can first choose either automated data labeling, but in case the machine, like the model cannot label it, then it will make a decision to either send it to a human reviewer, and humans will actually label the data. The service utilizes labeling UI templates which are web pages used to present tasks and instructions to workers. While the SageMaker console offers built-in templates, users have the flexibility to create custom templates using HTML 2.0 components. This feature allows for tailored labeling experiences that can be optimized for specific data types or labeling requirements. Seamless integration with AWS ML ecosystem. So the labeled datasets produced by Ground Truth can be used to train custom models or serve as input for Amazon SageMaker models. And this provides a seamless integration within AWS machine learning ecosystem, allowing users to move easily from data labeling to model training and deployment. So we are still at the stage of preparing our data, right? So because the data is there, but it's not labeled, and if it's unlabeled, we don't know what to achieve, right? So once if you finish that stage, you can there is seamless integration with the rest of the workflow, basically training the model, evaluating the model, and deploying the model. And that's all. Thanks for watching.